Okay, so today we're going to talk about lesson 1.3. This lesson's about linear functions, and it's another lesson where we're going to talk a lot about vocabulary and terminology. There won't be a ton of math, but there are some very important concepts here that we're going to use throughout the course, as far as how to identify linear functions and how to use them, and then how to interpret the results we get when we're working with these things. Okay, so let's talk about what a linear function is. So a linear equation in general is an equation where you have your variables, typically for us x and y, just to the first power. You can't have any second powers or anything like that. And there's a few different forms that we can use when we're writing these linear functions. The most common one that we'll deal with in this class is the slope-intercept form. It's going to look like this: y equals mx plus b. This is really useful for us. It's why we use it the most often here, because it's just the most powerful of these forms. We get the most information out of it because this value here, this m, this is our slope. We can just read it right off of there. Okay, sometimes we call that the rate of change. So the reason why slope-intercept form is so powerful is because this value here in front of the x is our slope, is our rate of change. We can read it right off of the equation. And this b value on the end here is the y value of our y-intercept. So this is going to show us where this graph is going to cross the y-axis. Okay, so if we look at a few different examples of what these things look like quickly, we could have something like y equals negative 5x plus 7. And this is definitely a linear equation because my x and y are to the first power here, right? And it's also in slope-intercept form because we've got this same setup with y equals mx plus b, and we know that this is going to be our slope. Sometimes we abbreviate that m. It's Greek, but yeah, that m is going to be our slope here is going to be this negative 5, and then this 7 on the end, that's the y value of our y-intercept. Okay, if you're trying to get an ordered pair for the y-intercept, the y-intercept's x value is always 0. So this is going to be 0, 7 is going to be where this linear equation crosses the y-axis. Okay, similarly over here, we've got some decimals. Doesn't change the fact that this is still a linear equation because our x and our y are both to the first power still. And this is, in fact, still in slope-intercept form. This is our slope. This is the y value of our y-intercept here, okay? We can also write this is in function notation, like we've talked about in a previous lesson. We can always replace the y with an f of x, put it into function notation. This is still slope-intercept form. All we've done is written it as a linear function this time, okay? So if we do that here, f of x equals 1/2 x minus 5. This 1/2 is our slope. And then 0, negative 5 is going to be our y-intercept over here. And then similarly, we have bigger numbers here. Doesn't change the idea. This is our slope. And then our y-intercept is 0 and 1175 for this one. Okay, so we can read, it's very, very powerful form for us because we can get our slope, we can get our rate of change, and we can get our y-intercepts just from reading the equation. Hey, there is another form that we can write these linear equations in. It's called the standard form. We won't use it very much in this class, but you do have a question or two on your homework. So I did want to bring it to your attention. It kind of looks like this: ax plus by equals c. There is not a easy way to get, you have to do a little rearranging to get the slope if you're given this form, but it does have some benefits. Like if we look at something here, just a couple of quick examples: 5x plus 8y equals negative 40. 3x minus 2y equals 18. These can be pretty nice to work with if you're trying to get the intercepts of the graph. It's one of the benefits of having this standard form equation. Let me show you what I mean. So if I have 5x plus 8y equals negative 40, and I ask you to find the x-intercept, something we couldn't really find easily from our standard form graph, all we're going to do to find the x-intercept is we're going to plug 0 in for y. And if we do that, it's just going to make this chunk of the problem that's got a y in it go away. So I'll just have a very simple equation left: 5x equals negative 40, divide by 5 on both sides, and I get x equals negative 8. And so negative 8, 0 is my x-intercept. Similarly, I can get the y-intercept pretty easily by setting x equal to 0. And again, it's just going to make this chunk of the problem that's got an x in it go away. So we'll have 8y equals -40. When we plug zeros into things, take advantage of that. We know that that piece of the equation just goes away. We just divide by 8 on both sides, get y equals -5. And so 0, -5 is our y-intercept. So one of the benefits to standard form is it's quite easy to get the intercept values, your x-intercept and your y-intercept value. If you want to find the slope, you have to rearrange it and put it into slope-intercept form. Certainly something we could do if we wanted to take this, put it into slope-intercept form. All we're going to do is we're going to take our equation, we're going to solve it for y. So I would start by moving this 5x over to the other side. And then I would just divide everything by 8. Just going to have a fraction here. That's okay. We're just going to leave it. And then over here, we can divide that out. Okay, so our y-intercept, I'm sorry, our slope is going to be that -5/8 there. Okay, so we could certainly work with standard form, but it is going to be less common in this class. We'll certainly focus much more on the slope-intercept form for these linear equations. Okay, so we may give you a situation like this where we give you a couple of points and we ask you to find the slope and the equation for a line that passes through these points. Okay, so we're still going to use our y equals mx plus b, our slope intercept form equation for situations like this. But in this case, we don't know what our slope is, and we're trying to write the equation for our line. So our first step is going to be to calculate that slope. And we do have a formula for that. Hopefully everybody's seen this before. If you haven't, it looks like this. It's y2 minus y1. We're going to do the difference in our y's on the top over x2 minus x1. We're going to subtract our x values on the bottom. And when you're looking at these 2 points, you want to pick one to be 0.2, one to be 0.1. It doesn't really matter which one is which, but what matters is that you're consistent. In this particular problem, my my 0.2 values are going to go in the front. So I'm going to make my larger points x2 and y2. Okay. And then my other point, those are going to be my x1 and y1. Okay, so I'll set this up. Y2 is 24 minus y1 is 4 over x2 is 10, x1 is 0, and then we'll just kind of work it out. So 24 minus 4 on the top gives me 20, 10 minus 0 gives me 10. Divide that out, and our slope is 2. And we're really halfway there. We're just trying to fill in the m and the b in this equation, and I've already got that the m is 2. Okay, so now I just need to fill in the b. There's a couple of ways you can do this. In this problem, my suggestion would be don't make this more complicated than it is. Remember what this is. This b value is the y-intercept, right? And when we're finding a y-intercept, we're looking for a point where our x value is 0, and we have that right here. This point has an x value of 0, so this is the y-intercept. You won't always have this situation, but when you do, you really want to take advantage of it. So our b value is 4. We can read it right off of there because that's the y-intercept, and that's what our b is. It's the y value of our y-intercept. And we're done. We've got the equation that we're looking for. We've calculated the slope that the question was asking for. That's everything we need for that particular problem. Okay, we'll certainly be giving you a few word problems that look like this in your homework assignment. Suppose the cost of a business property is $1.9 million. Company depreciates it with a straight line method. So this is important. It means we're going to be using linear equations because it uses the phrase straight line here. Okay, suppose that V is the value of the property after X years. And then it gives us a couple of points, this 20 and 1.36 million, and then 30 and 500,000 that the line passes through. Okay, and it just asks a couple of questions about this. We have a bunch of words here, but really what we've got here is our 2 points that our line passes through, and then it asks us to find the slope through these 2 points. So this is going to be very similar to our last one in that we're going to use our slope formula. M is equal to y2 minus y1 over x2 minus x1. Okay, and then we're just going to plug in. And again, it doesn't really matter which point is which. I'm going to make this 0.1 because, or I'm sorry, make this 0.2 because I want this big Y value first. Okay, it doesn't matter though. If you choose the other direction, you'll get the same answer. So you can't pick wrong. What you have to be is consistent. You can't start with this 1.36 million on the top and start with this on the bottom. You have to start with the values from the same point. Okay, so if I'm doing this, I'm going to have the 1,360,000 minus 500,000 over, again, I started with the 1.36 million on the top. I've got to start with the 20 on the bottom. Okay, and then we'll work this out. So that gives me 860,000 on the top. On the bottom, I get negative 10. We're going to divide that out. We'd get negative 86,000. Okay. And does it make sense that we got a negative value here? It does. This is a pretty important concept when you're thinking about slope. If your slope is positive, it means your graph is going to be increasing over time. In this case, though, if you look at our values, we went from 20 and a very large Y value to 30 and a much smaller Y value. So over time, this graph is going to be decreasing. So it makes perfect sense here that we would get a negative slope for this particular problem. Okay. It finally asks us, what's the annual rate of change of the value of the property? The nice thing, the reason why we care so much about slope is because that is what it gives us. It gives us the rate of change of things over time. And businesses really care about this. They want to see how their business profits or costs are changing over time, something that they're very interested in. So really, this question is just asking us to kind of interpret this value. Okay. And I'm going to read a little sentence. You'll just kind of be able to select one in the MyMathLab question. But if I wanted to interpret this, what this is telling me is that this is a decrease. Okay. And this is talking about the cost of a business property. Okay. That's changing over time. So what this is telling me is that the cost of my property, well, maybe I should use the word value. That would be better. The value of my property is decreasing at a rate of $86,000 per year. Okay. And do you think a business cares about how much their property values are decreasing over time like this? You bet they do. It's very, very important. So this is certainly something that's very applicable to the real world. Okay, so let's look at one more application problem. It looks complicated because there's a lot of words here, but if you understand the ideas behind linear functions, this question is one of the simplest ones we'll do in this entire class. So it says here that the monthly cost for the manufacture of golf balls is C of X equals 3170 plus 0.41X, where X is the number of golf balls produced each month. The first question asks us to find the slope of the graph of this cost function. Okay, so the key thing here is to recognize that this equation is a linear function in slope-intercept form. Okay, and so if we want to find that, remember y equals mx plus b is what we're looking at there. This m is our slope. We can read it right off the graph. So we just want to find our x term and look for the coefficient. And that 0.41 is our m, and that's the answer to the first question. That's the slope of our cost function. Okay. The second question asks us, what's the marginal cost, which it tells us is the rate of change for the cost function for the product? Well, the marginal cost, the rate of change of a function like this, is the slope. So that answer is also 0.41. Okay. The third question here asks us, what's the cost of each additional ball produced each month? So we want to think about the units here. So to get this slope, we do the kind of the y units over the x units. So the y units here are the cost. Okay. And the x units is the number of balls. So what this slope, again, the answer here, the number value is the slope again. It's just 0.41 dollars. That's my Y unit per ball, which is my X unit. Okay. And so what this is telling us is that if we increase our production, every extra ball that we produce is going to cost us 41 cents. Okay. And again, this is another very, very useful topic in the real world. Businesses very much care about how much increasing their production is going to change their costs over time. Okay. So again, all three of those questions, we don't have to do any calculations at all. We just use what we know about the slope-intercept form and linear functions in general, and we can answer them just based on what we're given there. Okay, so hopefully that's enough to get you started on this lesson. Please don't hesitate to send me an email if you have any questions or if there's anything at all that I can do to help. Have a nice day.